Hi, my name is Sudhir. Today we will discuss about amino acids and their structures and how to remember them easily.
Hi, I am Harsha, and today, as we discuss on the structures, I would just give a brief description on each structure. Firstly, amino acids are nothing but it's a building block of proteins. So there are 20 essential amino acids in our body, and these are very essential. And the normal amino acid structure would be like this. It would have a nitrogen bond, NH2, amide and two hydrogen bonds attached to it, and here there is a carboxylic acid group, C double bond O H. So that is why it is called amino acid, and it has a carbon link. It has a C bond here with attached to one hydrogen here, and here there is a gap. Here in this group itself, the amino acids link with different structural groups to form different amino acids. So we will discuss. And just give you a very easy way to remember. So I will give the structure to him, and he will just.
So this I am replacing the R group with one simple hydrogen. This is glycine, the first simplest amino acid, and this doesn't have any stereoisomers because this carbon is attached to two hydrogen atoms. And this is the starting amino acid where two carbon containing amino acid. This is glycine.
So as it looks like a small animal like dog. So and this glycine is also having a essential property as a neurotransmitter in the brain, in the central nervous system. It is acts as an inhibitory inhibitory neurotransmitter, glycine.
The next amino acid is valine. So I am removing the hydrogen and I am attaching an isopropyl group. This is isopropyl group, CH3CH3. So to just remember this valine easily, we can remember V shape of this isopropyl group, which is attached to glycine, where a hydrogen is removed. This is valine for V.
As we discussed about this valine, V represents the valine, and this is an aliphatic amino acid. It is very easy to remember when you look at the side chain of these amino acids. This is an aliphatic group, and as like glycine is also an aliphatic group. So valine is present in hemoglobin, and in sickle cell disease patients, these people would have a substitution with valine with glutamic acid. So glutamic acid is a hydrophobic one, so it is more prone to aggregation of this hemoglobin. So with sickle cell disease is formed.
Next amino acid is leucine. So we are using valine, where I am removing this V group and I am just adding this CH2, which is extra CH2, and again I am putting this V group. So this is leucine, where one more CH2 group is added to valine in between this amine containing nitrogen and this isopropyl group. This is leucine.
This is also an aliphatic amino acid, and this leucine is helpful in the protein synthesis and also helpful in the formation of sterols in the body.
Next amino acid is isoleucine. So this is an isomer of leucine, where one CH3 group is removed from second carbon. And here it is attached like this. Previously in leucine it was here, and in isoleucine it is attached here. Next amino acid is isoleucine. So from leucine, just this CH3 is added to third carbon, and hydrogen is replaced here. This is an isomer of leucine. In leucine, this CH3 group was there in this carbon, so this is removed and kept it in this position.
Isoleucine is also an aliphatic amino acid, and this is helpful in the formation of alpha-ketobutyrate and in the formation of acetyl coenzyme A.
Next we'll start from beginning. This is a glycine where one hydrogen is removed, and if we are adding a methyl group to this, it forms alanine. Alanine with one methyl group which is attached to CnH2 and COH.
So this ends with the aliphatic amino acid. So this alanine is helpful in the formation of glucose, especially in the time of gluconeogenesis. So alanine is formed into pyruvate. At the time of this formation of pyruvate, this nitrogen and NH2 is removed. It is called the deamination, and this NH2 removal will be formed in the formation of this urea.
So next amino acid structures which are based on alanine ring, where this CH2 will be retained and the rest of the groups will be added to this CH2 to form rest of the amino acids. In that, first amino acid is methionine, where one hydrogen from the alanine is removed and CH2S CH3 is added. So this methionine can be remembered because it is sulfur-containing amino acids. There are two sulfur-containing amino acids, cysteine and methionine. In methionine, two methyl groups will be attached side by side. You can remember methionine like that. And this CH2S CH3 is attached to alanine by replacing one hydrogen atom from alanine.
And this methionine comes under this classification of sulfur-containing group amino acids. And this methionine is also very helpful in the body function, especially from the formation of methionine from the homocysteine. So excess of homocysteine is very toxic. So homocysteine should form into methionine with the help of methionine synthase. So at this time, vitamin B12 plays as a cofactor in this methionine synthesis. And in the replication, DNA replication also, in the protein synthesis, methionine is the first amino acid to be started. It's called as a starting codon. It starts code with AUG.
So next amino acid is serine. So this is alanine. I'm adding OH to this CH2 group. So this is serine and it is a hydroxyl group containing amino acid. I added a OH group to this CH2, which is a part of alanine molecule.
And this serine is having the metabolism functions in our body, in the formation of in the synthesis of purines and pyrimidines, and also helps in the cell signaling molecule.
So next is cysteine from serine. Instead of hydroxyl group, we just add thiol group SH, sulfur and hydrogen. So this is cysteine.
And this cysteine molecule is having an antioxidant property, especially in the toxic effects of alcohol. It gives us an antidote for excessive toxicity, and in the liver toxicity when caused by maybe of paracetamol, and acetylcysteine is also given to counteract this toxicity. And I forgot to say this about this another amino acid called selenocysteine, which is actually a substitution with selenium is called as selenocysteine. So just in place of sulfur, there is a selenium compound, so it is called as selenocysteine, and it also have an antioxidant property.
Next is threonine. This is alanine, and I have removed two hydrogens. One is replaced with hydroxyl group, when it is replaced with the hydroxyl group, it forms serine. If you are adding one more methyl group to this, it forms threonine. This is alanine, one hydroxyl group serine and one methyl group threonine.
If you look at the structure, it has a hydroxyl group in this threonine. So this hydroxyl group plays a major role in this body functions, especially in this O-glycosylation takes place with this hydroxyl group, and the threonine helps in the phosphorylation.
Next we will discuss some of the aromatic amino acids with starting from alanine. Under this first amino acid is phenylalanine. So as the name suggests, it contains phenyl group C6H5 which is attached to alanine. So this is the phenylalanine.
And this phenylalanine is a precursor of many neurotransmitters like norepinephrine, dopamine and epinephrine. So this phenylalanine will be converted into the tyrosine, and tyrosine forms into L-dopa into the dopamine, and dopamine into norepinephrine and epinephrine. So these are all the neurotransmitters which are very much essential in our body to have these parasympathetic and parasympathetic functions.
So next is a tyrosine molecule. It's a hydroxyphenylalanine. So I am putting hydroxyl group para position to this, and it's made just from addition of a hydroxyl group to phenylalanine.
And this tyrosine molecule has a phenol group here, and this has a very good functional property. Because of this hydroxyl group in this position, it forms a hydrogen bonding with other molecules, and tyrosine helps in the phosphorylation in the protein synthesis and in the other cellular signaling molecules. This ATP would bind to this tyrosine with the help of tyrosine kinase, and which helps in the downstream cellular signaling properties.
Next amino acid is tryptophan. So this indole nucleus is attached to alanine. So this is tryptophan, where R group is substituted with indole nucleus. Indole again contains one benzene ring which is fused with pyrrole. So this is also called as benzopyrrole, and this is a structure of tryptophan.
This molecule also comes under the aromatic amino acid, and because of the presence of this and this one is a precursor of serotonin. Serotonin is nothing but it's 5-hydroxytryptamine.
Next amino acid is histidine. To remember this, again alanine, which is attached to 5-membered ring which contains 2 nitrogen atoms, that is imidazole ring. So imagine this is also a nitrogen atom, and this is a second nitrogen atom. So this is histidine. Next amino acid is aspartic acid. So it starts the dicarboxylic acid containing amino acid, and this is aspartic acid, where 2 carboxylic acid groups are there, 2 carbon atoms and 1 amino group.
And this aspartic acid is produced from oxaloacetate, and is also produced from the ornithine and citrulline from the urea cycle, and it helps in the gluconeogenesis pathway.
Next is glutamic acid, and this is also a dicarboxylic acid. I am adding just one CH2 group to aspartic acid, so it forms a glutamic acid. 2 carboxylic acids group, 1 amino group and 3 carbon atoms. Glutamic acid.
Glutamic acid is an accelerated neurotransmitter, and it helps in the learning and memory process in our brain. And in the patients of glioma and glioblastoma, this glutamate is mostly utilized by the brain.
And you can see amino acids like glutamine and aspartame. These are basic amino acids. Structure is similar, but carboxylic acid group is replaced with NH2 group, so it forms glutamine and aspartame. So next amino acid is lysine, where I am removing this carboxylic acid group and I just add one more carbon atom to this, and instead of putting carboxylic acid I am putting on NH2 group. So this is basic amino acid where 2 NH2 groups are there and only one carboxylic acid group is there, and we have 4 carbon atoms, and this is lysine.
And lysine helps in the absorption of calcium, and it will help in the bone growth, and also lysine would help in the formation of collagen, and collagen is a structural protein which is present in bone and any other matrix. So it helps in the stiffness of the bone and its growth.
So next and last amino acid is arginine. So to this lysine I am removing this NH2 and I am adding guanidine nucleus, and this is NH, C double bond NH, NH2, this is called guanidine. So as you know, it contains 4 nitrogens, and these are free. It can be protonated, and this is also a basic amino acid, and this is arginine.
And it helps in the healing of wounds, and also it is a precursor from the synthesis of nitric oxide, and sometimes this arginine can be used in the treatment of hypertension. Through the synthesis of this nitric oxide, it helps in the vasodilation, and it can treat the hypertension patients.
So here ends the amino acids and their basic structure and function, and I hope you got the easy method for remembrance of these structures.